Hello and welcome to Book Problems for Linear Motion. Get some paper and pencil out, take some notes. Remember, the notes that you take here can and most likely will be used as resource material when you take a test. How can you be both at rest and also moving about 107,000 kilometers per hour at the same time? When you answer the question, think relative motion. You can be at rest relative to Earth, but moving about 107,000 kilometers per hour relative to the sun. Next, you cover 10 meters in about 1 second. Is your speed the same as if you cover 20 meters in 2 seconds? Remember, this is average velocity. Average velocity, distinctly different. And the answer is yes. And the speed is going to be 10 meters per second. Ratios are equal. Next, does the speedometer of your car read instantaneous speed or average speed? Think when you're reading that speedometer, you're reading it at that split second of time, that instantaneous moment in time. So therefore, it would be instantaneous speed. Average speed equals distance covered divided by time traveled. Do some algebra and multiply both sides of this relation by travel time. What does the result say about distance covered? What does it say about distance covered? So you're solving for D, essentially. And the distance covered equals the average speed times time traveled. All right, now next, we're going to look at some more problems relative to relative motion, relative to linear motion, the difference between average velocity and instantaneous velocity. The difference between instantaneous and average velocities is the most important concept in the beginning of the chapter. Which is a vector quantity, speed, or velocity? Defend your answer. Velocity is a vector quantity. A description of velocity needs direction as well as magnitude. Speed needs only magnitude for its description. What two controls on a car cause a change in speed? What control causes only a change in velocity? Accelerator and brake pedal, steering wheel. What is the acceleration of a car moving along a straight line that increased its speed from 0 to 100 km per hour in 10 seconds? It would be 10 kilometers per hour per second. 10 kilometers per hour per second. By how much time does the speed of a vehicle moving in a straight line change each second when it is accelerating 2, 4, and 10 kilometers per hour second? 2 kilometers per hour, 4 kilometers per hour, and 10 kilometers per hour. Why does the unit of time enter twice in the acceleration? Once for the velocity change and once for the time change. Once for the speed change and again for the time change. Either way, same thing. What is the meaning of free fall? What is the meaning of free fall? I a little bit disagree with this answer, but free fall doesn't really have anything opposed to it. When you jump out of a plane, you're not free falling really because you have the air drag. Fall is free of air drag and forces other than gravity. For the freely falling object dropped from rest, what is the instantaneous speed at the fifth second of the fall, the 6th second of the fall? It would be 50 meters per second and 60 meters per second because you're accelerating 10 meters per second every second. For a freely falling object dropped from rest, what is the acceleration at the end of the 5th second of fall, the 6th second of fall? It's going to be 9.8 meters per second squared or 10 meters per second squared, it's at all times. It never changes. It's constant no matter what's happening to the object. How far will a freely falling object fall from rest in 5 seconds? That's from rest 1/2 GT squared. So that will be 10 times 5 squared. Well, sorry, 1/2 times 10 times 5 squared would be 125 and 180 respectively. How far will an object move in 1 second if its average speed is 5 meters per second? 5 meters, because it's going to be, the distance is velocity times time. How far will a freely falling object have fallen from its position of rest when its instantaneous speed is 10 meters per second? When it is 10 meters per second. Again, it's from rest, so the average speed will be 5 meters per second. So it'll be 5 meters. Same exact thing. Utterly and absolutely. It will be 5 meters. Next, what does the slope of the curve on a distance versus time graph represent? Well, it's the slope. Distance over time is the slope. Distance divided by time is speed, or velocity if you consider the direction. What does the slope of the curve of a velocity versus time graph represent? Well, change of velocity over change of time is acceleration. Does air resistance increase or decrease the acceleration of a falling object? Does it increase or decrease the acceleration of a falling object? It decreases it. It decreases the acceleration. It's going to slow down, and it's going to ultimately reach its terminal velocity. What is the appropriate equation for how fast an object freely falls from a position of rest for how far that object falls? Well, it would be V equals GT, and D equals 1/2 GT squared. V naught T falls out. Jogging Jake runs along a train flat car that moves at the velocity shown in the next picture. From greatest to least, rank the relative velocities of Jake as seen by an observer on the ground. Call the direction to the right positive. So you are the observer. Okay, so the A is moving 8 meters per second to the right, positive, and then the next one is 10 negative, then 10 positive, and then 18 positive, etc. You got it? Okay. All right. Now remember, let's see, it would be DCAB. DCAB. Is that what you got? DCAB. Below we see before and after snapshots of a car's velocity. The time interval between before and after for each of the same. Here we have it. Before and after A, before and after B, before and after C, before and after D. Okay, so you've all seen those now. This is the question. Well, it's coming up. So before and after, so it's going to go from 10 to 20, 0 to 10, 20 to 15, 15 to 15. All right, you're all set. Below we see before and after snapshots of the car's velocity. The time interval between before and after for each is the same. Rank the cars in terms of the change in velocity from most positive to the most negative, and rank them in terms of acceleration from greatest to least. Rank them in terms of acceleration from greatest to least. You're going to want to go back and look at this. Make sure you can do this. A equals C, and then it will be D, and then B. And B is the same thing. A equals C, and then D, and then B. Okay? These are drawings of same-sized balls of different masses thrown straight downward. The speed shown occur immediately after leaving the thrower's hand. Ignore air resistance. Rank their accelerations from greatest to least, or are the accelerations the same for each? Well, it's falling, so I don't know, they're falling, so they're in a gravity well. So I don't know, what do you think? Try to reason it out. Remember, you can always stop, rewind. All right, so what do we do again? It says these are drawings, blah, blah, blah. Rank their accelerations from greatest to least. Or are the accelerations the same for each? Accelerations. Well, they're all equal because it's in a gravity well. What's the acceleration in gravity? It's all 10 meters per second squared. 10 meters per second squared. Doesn't change. It's always the same. A track is made of a piece of channel metal bent as shown. A ball is released from rest at the left end of the track and continues past the various points. Rank the balls at points A, B, C, and D from fastest to slowest. Again, watch for tie scores. Okay, C, B equals D, and then A. Good, excellent. Remember to rewind if you have any questions about these. Next, look, we see ball A, B, C. All right, so you have a couple of changes here. The slope in the beginning is all the same. Okay, a ball is released from rest at the left end of 3 different tracks. The tracks are bent from the same metal of the same length. From fastest to slowest, rank the tracks in terms of the speed of the ball at the end, or do all the balls have the same speed there? Okay. Well, what do you think? B, and then A equals C is the same. Okay. Next, from longest to shortest, rank the tracks in terms of the time for the ball to reach the end, or do all balls reach the end at the same time? Do they reach the end at the same time? Well, it'll be C, then B, and then A. C, B, A. From greatest to least, rank the tracks in terms of the average speed of the ball, or do the balls all have the same average speed on all 3 tracks? C, B, A. C, B, A. Does that make sense? If you have any questions, please ask me to go over it in class. In the speed versus time graphs, all times T are in seconds and all speeds V are in meters per second. From greatest to least, rank the graphs in terms of the greatest speed at 10 seconds. A, C, B. A, C, B. Greatest, all right, now from greatest to least, rank the graphs in terms of the greatest acceleration. Well, there's really only one's accelerating, is C. A and B are both 0. A and B are equal. They are both 0. From greatest to least, rank the graphs in terms of the greatest distance covered in 10 seconds. It would be A, C, and then B. A, C, B. And that's distance covered in 10 seconds. These are to familiarize you with the central equation of the chapter. Calculate your average walking speed when you step 1 meter in 0.5 seconds. It would be 1 meter divided by 0.5 seconds. Calculate the speed of a bowling ball that moves 8 meters in 4 seconds. It would be 8 meters divided by 4 seconds is 2 meters per second. Easy. Calculate your average speed if you run 50 meters in 10 seconds. Well, it'd be 50 meters divided by 10 seconds, which is 5 meters per second. Very basic. Calculate the distance in kilometers that Charlie runs if he maintains an average speed of 8 kilometers per hour for 1 hour. It would be, distance is velocity times time. It would be 8 times 1, which would be 8 kilometers. Calculate the speed if you will travel if you maintain an average speed of 10 meters per second for 40 seconds. 10 times 40 is 400 meters. Calculate the distance in kilometers you will travel if you maintain an average speed of 10 kilometers per hour for a half hour. That's going to be 10 times 0.5 is 5. Calculate the acceleration of a car in kilometers per hour per second that can go from rest to 100 kilometers per hour in 10 seconds. And that's going to be a change in velocity, which is 100 kilometers per hour divided by 10 seconds is 10 kilometers per hour per second. Calculate the acceleration of a bus that goes from 10 kilometers per hour to a speed of 50 in 10 seconds. And it would just be 50 minus 10 is 40. Divided by 10 is 4 kilometers per hour per second. 4 kilometers per hour per second. Pretty tricky, that one. I'm being facetious. Calculate the acceleration of a ball that starts from rest and rolls down a ramp and gains a speed of 20 meters per second in 5 seconds from a rest position. It's going to be 20 minus 0. 25 minus 0 is 25 divided by 5 is 5 meters per second squared. Calculate the instantaneous speed in meters per second at the 10-second mark of a car that accelerates from 200 meters per second from a position of rest. So it's going to be AT is going to be 2 times 10 is 20 meters per second. V equals AT. Calculate the speed in meters per second of a skateboarder who accelerates from rest for 3 seconds down a ramp at an acceleration of 5 meters per second. Again, V equals AT. 5 meters per second squared times 3 is 15 meters per second. That is going to be the velocity, instantaneous velocity. Calculate the instantaneous speed of an apple 8 seconds after being dropped from rest. 8 seconds after being dropped from rest. Dropped is the operative word there. Again, V equals GT this time. That'll be 80 meters per second velocity acquired in a free fall from rest. On a distant planet, a freely falling object has an acceleration of 20 meters per second squared. Calculate the speed an object dropped from rest on this distant planet would be 20 times 1.5 is 30 meters per second. 20 meters per second squared is the acceleration. A skydiver steps from a high-flying helicopter. If there were no resistance, how fast would she be falling at the end of 12 seconds? It would be 10 times 12 seconds is 120 meters per second would be the velocity at the end of that time. Calculate the vertical distance an object dropped from rest would cover in 12 seconds. If it fell freely without air resistance, it would be 1/2 AT squared, or 1/2 GT squared in this case. And that would be 720 meters. 720 meters. An apple drops from a tree and hits the ground 1.5 seconds later. Calculate how far it went. Well, 1/2 GT squared, it dropped from rest, and that's going to be calculated 1/2 gt squared at gt squared, and it'll be 11.3 meters. Light travels in a straight line at a constant speed of 300,000 kilometers per second. What is the light's acceleration? It has none, because it's at a constant velocity. And that's the end of it. 43A, if a freely falling rock were equipped with a speedometer, by how much would its speed readings increase for each second of a fall? 10 meters per second, because that's the acceleration in gravity. No secret. It would be 10 meters per second. Every second would be the increase. Suppose a freely falling rock were dropped near the surface of the planet, where g is 20 meters per second squared. By how much would its speed readings change each second? 20 meters per second, because that's the new acceleration. It will fall according to whatever the planet's acceleration due to gravity is. If it was 150, it would fall at 150. It would increase to that much. Which has more acceleration when moving in a straight line? A car increasing the speed from 50 to 60 kilometers per hour, or a bicycle that goes from 0 to 10 kilometers per hour? Same, each undergoing the same change in speed during the same amount of time, same acceleration. Because acceleration is change in velocity over change in time. Correct your friend who says the dragster rounded the curve at a constant velocity of 1 kilometer per hour. Aha, it wasn't a constant velocity because the direction was changing. Constant velocity means constant direction. So your friend should say at a constant speed of 100 kilometers per hour. 100 kilometers per hour. What is the acceleration of a car that moves at a steady velocity 100 kilometers per hour due north for 100 seconds? Explain your answer and state why this question is the exercise in carefully reading as well as physics. 0, for no change of velocity occurred. Misreading the question might mean missing the word steady or no change. Steady, meaning no change. Tiffany stands on the edge of a cliff and throws a ball straight up at a certain speed and another ball straight down at the same initial speed. Neglect air resistance. Which ball is in the air for the longer time? A, longer time for ball thrown upward. Longest time for ball thrown upward. Why is that? Very interesting. Which ball has the greater speed when it strikes the ground below? Which ball has greater speed when it strikes the ground below? Both hit the ground at the same speed. When upward as ball returns to original level, it has the same speed. Ball thrown downward. A ball is thrown straight up. What will be the instantaneous velocity at the top of its path? What will be its acceleration at the top? Why are both answers different? It will have 0 will be the instantaneous velocity, but g always remains the same. So it's going to have 10 meters per second squared will be the acceleration at the top of the arc. Two balls are released simultaneously from rest at the left ends of the equal length tracks A and B as shown. Which ball reaches the end of its track first? Ball on B finishes first, for it gains extra speed in the dip, which makes overall higher average speed on track B. Does the ball on B roll faster in the dip than the ball rolling along track A. Interesting. Very interesting. Yes, ball B is faster in dip than the ball on track A. And the ball on track A. On track B, is the speed gain going down into the dip equal to the speed loss going up the dip? If so, do the balls then have the same speed at the ends of both tracks? Yes, speed gain going down equals speed loss going up. So both balls have the same speed at the end of their tracks. They have the same speed at the end of their tracks. Remember that. Is the average speed of the ball on the lower part of track B greater than the average speed of the ball on A during the same time? Yes, average speed on lower part of track B is greater than the speed of the ball on track A. So overall, which ball has the greater average speed? Do you wish to change your answer to the previous exercise? Do you wish to change your answer to the previous exercise? Ball on B has greater average speed because it moves faster on the lower part of the track. Many people get the wrong answer to 48 due to assumption that because the balls end up with the same speed that they roll or the same time. Not so. Not so, said the blind man. A dragster going at 15 meters per second north increases its velocity to 25 meters per second north in 4 seconds. What is the acceleration during this time interval? Well, it would be 15 minus 25, 25 minus 15 divided by 4, which would be 2.5 meters per second squared. Remember, it's change in velocity over change in time. So it would be 25 minus 15 divided by 4 is 2.5 meters per second squared. An apple drops from a tree and hits the ground 1.5 seconds, in 1.5 seconds. What is its speed just before it hits the ground? What is its speed just before it hits the ground? Well, it would be V equals GT would be the equation. V equals GT. So it would be V equals 10 meters per second squared times 1.5 seconds, and that equals 15 meters per second. 15 meters per second. Next, on a distant planet, a freely falling object has an acceleration of 20 meters per second squared. What vertical distance will an object drop from rest on this planet cover in 1.8 seconds? Cover in 1.8 seconds. Well, it's going to be d equals 1/2 gt squared. D equals 1/2 20 meters per second squared is the acceleration times the time. 1.8 seconds squared would be 32.4 meters. 32.4 meters. If you throw a ball straight upward at a speed of 10 meters per second, how long will it take to reach zero speed? Well, delta t is delta v over a, so it'll be 10 meters per second over 10 meters per second squared, or 1 second. How long will it take for the return to the starting point? 2 seconds. 1 second up, 1 second down. 1 second up, 1 second down. How fast will it be going when it actually reaches the ground? Well, it's 0 at the top, and then it falls for 1 second, and it will maintain, it'll reach a speed of 10 meters per second. 10 meters per second. Because of gravity, acceleration due to gravity. Hannah tosses a ball straight up with enough speed to remain in the air for several seconds. What is the velocity of the ball when it reaches its highest point? So it's going to lose speed at 10 meters per second every second. So when it reaches the top, it will be at 0. We're going to have a lot of quizzes on this exact issue in the coming days after you see this lecture. But what is its velocity 1 second before it reaches the top? What's its velocity 1 second? Well, think about it. If it's going to be 0 at the top and it loses 10 meters per second every second, it's got to be 10 meters per second going straight up, because it will lose the 10 seconds, it will lose the 10 meters per second in that 1 second to become 0. So 0 is known. Now, what is the change in its velocity during this 1 second interval? Well, it's going from 10 meters per second to 0, so it's going to be 10 meters per second is going to be the change. So it's going to decelerate at a rate of 10 meters per second squared. Now, sometimes the book will say it's negative, sometimes 10 meters per second squared, some say it'll positive. We'll discuss that before individual problems, not to worry. What is its velocity 1 second after it reaches the point? Well, according to the acceleration due to gravity, when it reaches the top and is going back down, it's going to be going 1 second after the top, it's going to be going 10 meters per second straight down. Now, this is something that I think is pretty important, and that is that this graph is not drawn to scale. So please remember that. It's just drawn so that you can understand basics of what's going on. What is the change in velocity during this 1 second interval? Well, it's going to be 10 meters per second, because it's going to be going 10 meters per second. It starts at 0, and then it's going to be going 10 meters per second. So its acceleration will be 10 meters per second squared. Now, Kenny Klutz drops his physics book off his aunt's high-rise balcony. It hits the ground below 1.5 seconds later. Now they're going to ask things like, how fast was it going? What was the distance covered? What was the instantaneous velocity? Well, how do you get the instantaneous velocity? And that is that v equals gt. So it'll be going 15 meters per second. That'll be the speed or the velocity. It'll be going straight down. And there's the calculation. There's about 5 or 6 very important equations in this type of physics, and v equals gt is one of them. V equals gt is the way to get instantaneous velocity. All right, how high is the balcony? Well, it's starting from rest. Now remember, d equals v naught t plus 1/2 gt squared. It's starting from rest, and that v naught will cancel because v naught is 0, so that first term will cancel. So you're left with d equals 1/2 gt squared, and that's going to be 11.3 meters. Don't forget to square the 1.5. Don't forget it's half the 10, half of g, and then multiply it by 1.5 squared, and in this case, it's 11.2. Calculate the hang time of an athlete who jumps a vertical distance of 0.7 meters. Now this is a little confusing because you're using d equals 1/2 gt squared and you're solving essentially for t. And that is going to be 1/2 gt squared, then t equals 2d over g, and then that's going to equal 0.77 is going to be t, and then that's going to be how high, you know, that's not really the hang time, that's how high it's going to be. It's going to take 0.77 seconds to reach the top, and then it's twice that coming down. So the resulting value will be 2 times 0.77, and we'll see that on the next slide. So you can see here what is going to be the hang time. 0.77 seconds is not the hang time. That's just how far the athlete jumped. Now, if you thought of it this way, if he falls from 0 and he falls for 0.77 seconds, he's going to fall according to gravity. And according to the equation, d equals 1/2 gt squared, he's going to be falling that distance. Okay, that distance he's going to be falling. So if you plugged in and said, well, okay, fair enough, it's going to be 2 times the square root of 2 times 0.75 meters divided by 10 meters per second squared, according to the equation, is 0.77 seconds, so you'd fall 0.7 seconds. So if you're going up 0.77 seconds and then down 0.7 seconds, what is going to be the actual hang time? Now, this makes it quite clear. It's 0.77 seconds up, 0.77 seconds down, of a total hang time of 1.54 seconds. Total hang time. Now, a question. If instead of jumping straight up, the athlete ran as fast as he could and then jumped, much like Michael Jordan used to do, or Kobe Bryant, where they're just leaping through the air and they get that incredible push from the floor, will their hang time be greater if they were up for 0.77 seconds? If they jumped higher, fair enough, it would be a greater hang time. But if they jumped up the same height, would they stay up longer if they ran and then leaped? So they had that horizontal velocity working for them. What would the horizontal velocity do to the ability to stay up vertically? Question. That's a question. That's very important. One of the most important aspects of what we're going to study next, called projectile motion. So that's your transition to projectile motion, the next chapter.